In this lecture, we're going to look at the use of zero exponents and negative exponents and some of the things we can do with that. So what we will start with is a definition for, first of all, working with zero exponents, or rather an exponent of 0. If we have some number a, and it is raised to the 0th power, it is equal to 1. The only catch here is that a cannot be equal to 0. We can write that in words that any number to the 0th power is 1. Hopefully I spelled that 0th correctly. And this can be a very handy thing. Some examples, just rewriting some numbers. If we have 2 to the 0th power, that is going to be equal to 1. If we have 126 to the 0th power, that is going to be equal to 1. If we have a really fun-looking number like negative 15, make a big expression out of this one, z to the 3rd, y to the 16th power, and we take that entire expression and raise it to the 0th power, again, it all goes away very handily to 1. You do have to be mindful of parentheses when you're working with this definition. You'll notice that the negative sign in this expression is inside the parentheses. So what you really have there is a negative 1 times 15 and all that other good stuff raised to the 0th power. Well, negative 1 to the 0th power is also going to get us 1. If, however, we have a negative sign and it is outside of parentheses, for instance, a negative 5 raised to the 0th power, we have to remember that the power is only associated with the number or letter right next to it. It's a nearest neighbor. So we have 5 to the 0th power. Well, we can rewrite that one as a negative 1 then times 5 to the 0th power, which is a negative 1 times 1, and that will leave us with a negative 1. These sorts of problems, or the application of this rule, comes into play if you have something like x times y raised to the 5th power, and you're dividing that by y raised to the 5th power. If you don't see right away that you can just cancel out the y to the 5th because they're the same, you can apply the quotient rule, and then you have x times y to the 5 minus 5 power, but that's x times y to the 0th power, and that would be x times 1, which is simply x. Again, the catch here is that y is not equal to 0. Now, the second goal that we have is to work with negative powers. And so again, I'm going to start with a definition. If we have a number raised to the power negative n, we're simply going to write that as 1 over that number raised to the power n. If we have 2 to the negative 1 power, we can simply go right back to our definition. A to the negative n is 1 over a to the n, and rewrite that as 1 over 2 to the first power, which is simply 1/2. You can remember this a couple of different ways. One helpful tip that I have that has worked for many people is that you have two flavors of negative signs to work with. Let me write that out. The first kind of negative sign you've been working with for quite some time, it's when you have a number like -5. That means that you are left of 0 on the number line. The second flavor of negative that you're working with is this negative in the power. What happens there is that a negative power crosses the line. If you have a hard time remembering that, you can make up a story for yourself. That's often helpful. Maybe think of somebody pounding with a hammer right outside your window at night, or in your office doing construction, and eventually the noise gets so negative that it crosses the line. Something like that. It crosses the line between the numerator and the denominator, or if you prefer, top and bottom. So we will use that, working with some examples. You'll notice when it crosses the line, when your number crosses the line, the sign on the power changes, becomes positive. But the sign in front of the number does not. I'll call that the sign, let me move this paper here, out front. So let's look at some, does not change, some examples. Suppose you have that says example. Yeah. Suppose you have a number like 1/3 to the -1 power. We can work through this as a fraction. The 3 to the -1 is simply going to become a 1/3. So we'll leave the 1 in the numerator, and in the denominator we now have a 1/3. What you may recognize is that here you have a division problem. You have 1 divided by 1/3, pardon me, ignore that line. We have 1 divided by 1/3. Whenever you divide by a fraction, you take the reciprocal of the second number of the divisor, which means you're going to flip it over, and you multiply. So we have 1 times 3, which is simply 3. Now, we can write this with a power, and that's useful as far as getting back to our rule for negative powers. We could write that as 3 to the first. Then, if we look at that, we have 1/3 to the -1. That became 3 to the first. What happened? The thing that had the negative power on it has crossed the line from the denominator to the numerator. When it crossed the line, the power became positive. But the number itself did not change sign. There is no sign change. Out front. And again, that gets back to thinking in terms of two flavors of negative signs for this type of problem. Let's do another kind of example, one that's a little more interesting. Suppose we are to simplify 2 raised to the negative 2 power divided by 3 raised to the negative 3 power. Again, we notice the negative powers. So we'll take one at a time and think about where those numbers are going to move. We have a 2 raised to the negative 2 power. It needs to cross the line. It will cross the line into the denominator. We have a 3 raised to a negative 3 power. So it too will cross the line into the numerator. So this entire thing is going to do a sort of a flip. When we do that, we'll have, moving the 2 first, we'll have 2, now it's raised to the positive 2 power in the denominator. Notice that the sign is changing on the power. And moving the 3 up, we have 3 raised to a positive 3 power. Now we don't ordinarily write those pluses in there, so we'll just write that as 3 to the 3rd over 2 to the 2nd power. I just did that to emphasize the change in the sign on the power.